Welcome to Surds Level 2, one step in a level by level practice course. Pause the video now, try the problems on the screen, and I'll go through them with you shortly. At the end of the video, you can use the end screen to either practice more at this level or move up to the next one, and you can find topic by topic playlists on the channel homepage. In problem 1, we're simplifying the square root of 54 plus the square root of 150. Now when we add and subtract surds, it's very similar to collecting together like terms. We can only add or subtract when the surd parts are the same, and at the moment they're not. So what we're going to aim to do here is simplify each of the surds to have the same surd parts in each, and then we can add or subtract them. Now it's best to start with the smallest number under the surd, so that's the square root of 54, and we're going to find two numbers that multiply to make 54, where one is a square number. And looking at this list, 54 can be divided by 9. So we can rewrite the square root of 54 as the square root of 9 multiplied by the square root of 6, because 9 times 6 is 54. Now because 9 is a square number, we can square root it. So the square root of 9 is 3, so this becomes 3 root 6. Moving on to the square root of 150, we now know that we want part of this to have the square root of 6 in it. And because 150 divided by 6 is 25, the other part must be the square root of 25. And 25 is a square number, so we can square root that again, and the square root of 25 is 5. So this becomes 5 root 6. Putting these back into our original sum, we have the square root of 54, which is 3 root 6, plus the square root of 150, which we can now write as 5 root 6. Now like 3x plus 5x would give you 8x, 3 root 6 plus 5 root 6 gives us 8 root 6. So 8 root 6 is our final answer to problem 1. In problem 2, we're simplifying the square root of 72 minus the square root of 200. Again, what we need to do here is try and simplify the surds so they both contain the same surd part. And we're going to start with the smallest, which is the square root of 72. Now using our list of square numbers, we can see that 72 can be divided by 4, and it can be divided by 9, but it can also be divided by 36. And when we simplify surds, we want to try and take the largest square number we can. So we're going to rewrite the square root of 72 as the square root of 36 times the square root of 2, because 36 times 2 is 72. Now the square root of 36 is 6, so this becomes 6 root 2. Moving on to the square root of 200, because we want to simplify this, we know that one of our two surd parts needs to be the square root of 2 to match the one above. Now 2 times 100 gives us 200, so this is going to be the square root of 100 times the square root of 2. Now 100 is a square number, and we can square root that to give us 10 root 2. So going back to our original sum, we have the square root of 72, which we can write as 6 root 2, minus the square root of 200, which we can now write as 10 root 2. Now 6 minus 10 is minus 4, so 6 root 2 minus 10 root 2 is minus 4 root 2. And that's our final answer to problem 2. In problem 3, we're simplifying 2 root 27 plus the square root of 192. Now again here, to collect these two together, we need their surd parts to be the same, and we can achieve this by simplifying. So starting with the smaller surd, which is the square root of 27, we can check our list of square numbers and see that 27 can be divided by 9, because 9 times 3 is 27. So we can rewrite 27 as the square root of 9 times the square root of 3, and because the square root of 9 is 3, this becomes 3 root 3. Moving on to the square root of 192. This is a large number, so it's a bit more difficult to split up, but we know that part of this needs to have a square root of 3 in it to match what we had above. So to find the other surd part, we can do 192 divided by 3, and this gives us 64. So we can write this as a square root of 64 times the square root of 3, because 64 times 3 is 192. Now 64 is a square number, so we can square root it, and the square root of 64 is 8, so this becomes 8 root 3. So going back to our original sum, we have 2 times the square root of 27, this becomes 2 times 3 root 3, plus the square root of 192, which is plus 8 root 3. Now 2 times 3 root 3 becomes 6 root 3, because 2 times 3 is 6, and we still have a plus 8 root 3 at the end. And finally, 6 plus 8 is 14, so 6 root 3 plus 8 root 3 is just 14 root 3. And that's our final answer to problem 3. In problem 4, we're simplifying the square root of 44 plus 2 root 99 minus the square root of 275. Again here, to collect these together, we need the surd parts to match, and they don't at the moment, so we're going to have to simplify. So starting as we always do with the smallest surd, root 44, we can see here that 44 can be divided by 4 from our list of square numbers and no other numbers. And 4 times 11 is 44. So we can rewrite the square root of 44 as the square root of 4 times the square root of 11. And because the square root of 4 is 2, this becomes 2 root 11. We can now move on to the square root of 99. And again, in this, we know that we're going to have a square root of 11 so that we can simplify it with the one above. And 9 times 11 makes 99. So this becomes a square root of 9 times the square root of 11. And the square root of 9 is 3. So this becomes 3 root 11. Finally, we can look at the square root of 275, which is a larger number to split up. But again, here we know that we want the square root of 11 to be in part of this. So we can say, what is 275 divided by 11? And that gives us 25, which is useful because 25 is a square number. So the square root of 275 becomes a square root of 25 times the square root of 11. And the square root of 25 is 5. So this becomes 5 root 11. And we can now put each of these 3 simplified surds back into the original sum. So the square root of 44 becomes 2 root 11. We then have plus 2 times the square root of 99, which is 2 times 3 root 11, minus the square root of 275, which is 5 root 11. Now looking at that term in the middle, 2 times 3 root 11 is 6 root 11. So we have 2 root 11 plus 6 root 11 minus 5 root 11. And we can now collect these all together to get our final answer. So here, 2 plus 6 is 8, minus 5 is 3. So that means 2 root 11 plus 6 root 11 minus 5 root 11 is 3 root 11. And that's our final answer to problem 4.